Welcome back. This is Algebra 2, Chapter 6, Section 1. This is page 3 of the notes. We have one example here, which is some sort of word problem style example about animal population. It's meant to give you a little bit of practice using exponents on real world problems. They give you the formula here. P equals C times 1.21 to the t over 3. And it tells you C is the initial population. Find the population after 19 months if the initial population was 75. Okay. So, initial population was 75. That means that is C. And 19 months, 19 months, that means that 19 is T. So we're going to go ahead and put those numbers in here. We have 75 times 1.21 to the 19 over 3. And then, in this case, if you really wanted an exact answer, that's it. But realistically, these real world situations, you want some sort of approximate version you can work off of. And it's about 250.8-ish. So the population of the species is about, and then here I'm just going to go to the nearest whole number because it makes most sense when you're talking about populations of things to have a whole number. But it's about 251 after 19 months. So then we have a checkpoint. We've got 3 problems left. First of all, you have problem 3 here, which says evaluate negative 125 to the negative 2/3 power. So that means it's 1 over 125 to the 2/3 power, because remember, negative exponents mean denominator. So that's 1 over, and I'm going to do the radical version here because I ended up liking that one better. The cube root of 125 squared. And you might know that the cube root of 125 is 5, and I realize I made a mistake. It's negative 125 for all of this business. So it's the cube root of negative 125 squared. So I'm sorry about that. Let's go back here. We have 1 over cube root of negative 125 is negative 5. Remember, because it's an odd root, you can do odd roots of negative numbers. So it's negative 5 squared. But negative 5 squared is positive 25. So your final answer here is 1/25. Over on problem 4, it's a slightly different situation. You're starting with y minus 3 to the 4th equals 200. And then you need to begin by doing 4th roots. So we have y minus 3 equals the 4th root of 200. But because this is an even root, positive number inside, it's plus or minus. There's 2 things. Again, we saw this before when we were doing square roots. Same for any even number root. And then, we finish up by adding 3 to both sides. We add 3 to both sides. You get y equals 3 plus or minus the 4th root of 200. And, if you want exact answer, there you go. If you want an approximate answer, we're talking about 6.76-ish or negative 0.76-ish. Those are our answers when we've gone ahead and plugged those numbers into our calculator. If you need help evaluating these roots on your calculator, please let me know. I'll be happy to show you. Every calculator is different, so it's pretty much one-on-one instruction, but that's where we are, and I'd be happy to help you there. Finally, to finish up, we have this problem 5 here on the checkpoint, The volume of a cone is given by V equals pi r squared h over 3, which is true, where h is the height of the cone and r is the radius. Find the radius of the cone whose volume is 25 and whose height is 6. This is a great problem, a little bit complicated, but I think you could probably manage your way through, at least getting started. The volume is 25, it says, so V is 25, and the height is 6, so h is 6. That's meant to indicate that V is 25 and h is 6. I'm sorry, we're not dividing. But anyway, if we write the formula, V equals pi r squared h over 3, that's just kind of the formula. And then if we substitute in our numbers, we get 25 equals pi, don't know r, so pi r squared, h is 6 over 3. Now, one nice thing is that here, 6 over 3, that reduces to 2. So we can rewrite this as 25 equals 2 pi r squared. And then we can now just go ahead and divide both sides by 2 pi. So we get r squared equals 25 over 2 pi. That's almost great. We're not quite there. We need the radius, though. So the radius equals, and here we have square root 25 over 2 pi. Now, everything else in this section should have trained you to write plus or minus in front because it's an even root. However, since this is a real-world style problem, the radius can't possibly be a negative number. So it's exactly the square root of 25 over 2 pi, and so the radius, the radius is approximately 1.99. And let's go ahead and throw the units inches on there. There you go. That's the end of this checkpoint. Let's put a box around it to make it look official. That's the end of this page. That's the end of this section. Thank you for watching.